Hi everyone, we're almost finished. Here we have our next topic, applications of integration. Now one of those applications is finding the area bounded by curves and lines. Let's just look at an example to see what I mean. First example says, determine the area of the shaded region bounded by the curve y equals 9x squared minus 8x plus 1, the x-axis, and the lines x equal 1 and x equal 5. So here we have part of the curve y equal 9x squared minus 8x plus 1. And here we have our x-axis, and we have the lines x equal 1 and x equal 5. So these are the boundaries, and we want to find the area of this shaded region. Now to do that, we'll be applying definite integral. Now, with definite integral, we have an upper and a lower limit. Now the upper limit in this case will be where x is equal to 5, and the lower limit is where x is equal to 1. F of x will simply be the equation of the line or curve, depending. So now, with definite integral, if you recall, we will integrate the function, and the answer that we get, we're going to plug the upper limit in the first bracket, subtract sign, then the lower limit in the second bracket. So let's go ahead and see what this area yields. So let's integrate. We add 1 to a power of 2 to get 3. Divide by that 3. Here x already has a power of 1, so when I add 1 to it, I get 2 and divide by 2. And if I integrate 1, I simply get x. So now, the function I'm left with when it's simplified is 3x cubed minus 4x squared plus x. And this is the function I'm going to plug my limits into. So first I'm going to plug my upper limit into the entire function and substitute this 5 wherever we have an x. So this becomes 3 times 5 cubed minus 4 times x minus 4 times 5 squared plus 5, as you see here, minus sign in the middle. Now for the lower limit, 3 times 2. This should be a 1 and not a 2. Let me fix that, because here the lower limit is in fact 1. Now we plug the lower limit, 3 times 1 cubed minus 4 times 1 squared plus 1, as you see in this second bracket. So now when we simplify, 5 cubed is 125 multiplied by 3 gives us 375. 5 squared is 25. 25 times 4 gives us 100. And our 5 comes down. When we work this bracket, we get 200. In this lower bracket, 1 cubed is 1, 3 ones 3, 1 squared is 1, minus 4 times 1 is negative 4, the 1 comes back. 3 minus 4 is a negative 1, and negative 1 plus 1 is a 0. So this bracket yields a 0. So now our answer becomes 280 minus 0 equals 280 units squared. Since we're finding area, we will just square the unit. That's how we express it. So once more, to find the area under a curve, we simply integrate the equation of the curve, and the limits can be found from the boundaries if you're given a graph like this. Now, you are not always given a graph. If you look in the question that follows, it says, find the area of the region bounded by the curve y equal x plus 4 over x squared, the x-axis, the lines x equal 1 and x equal 3. So these are our four boundaries: the curve, the x-axis, and the lines x equal 1 and x equal 4. So it's just as we did earlier. We're going to integrate the y function and plug the upper and lower limit inside the answer. So here we have our x plus 4 over x squared that we need to integrate. Now, first I brought my x squared up and raised it to a negative 2. So now let's integrate. This x is already as a power of 1, so when we add 1 we get 2 and we divide by that 2. Add 1 to negative 2 to get negative 1 and divide by negative 1. So our integral now becomes x squared over 2 plus, not plus, this becomes a negative 4x to the negative 1. And another way of writing negative 4x raised to negative 1 is by simply taking this x and bringing it below, and it's now raised to a positive 1, as you can see. So this is our integral in which we are going to plug our upper and lower limit. So let's plug, first we plug our upper limit. So we have 3 squared over 2 minus 4 over 3 in our upper bracket, minus sign in the middle. Now for the lower, 1 squared over 2 minus 4 over 1. Now 3 squared over 2 is 9 over 2. 9 over 2 minus 4 over 3 gives 19 over 16. Negative sign goes back. A half minus 4 is negative 3.5, or negative 7 over 2. So when we have these two negative signs together, it becomes a positive, and when we add these values, we get 20 over 3 as our area. In the second question, it says, find the area of the region bounded by the curve y equals sine 2x, the x-axis, and the lines x equals 0 and x equals pi over 4. Similarly, we are going to integrate our y function, then plug the upper and lower limit. Now if we integrate sine 2x, we get negative 1 over 2 cos 2x. So that's what we have here, and this is where we're going to plug our upper and lower limit. Now our upper limit is pi over 4. Now 2 times pi over 4 is going to give us a pi over 2 in this upper bracket. Minus sign goes back, and 2 times 0 for the lower bracket is 0. So that's why we have cos 0 here. Now we get our calculator and we're going to evaluate cos pi over 2. Remember, your calculator has to be in radians. So cos pi over 2 gives us 0. So this is a negative half times 0, which is 0. Minus sign goes back. Here we have cos 0, which is 1. And this becomes negative half times 1, which is a negative half. So now these two negative signs together makes our answer a positive half unit squared. Now, just as how we can find the area below the curve, we can also find the area between two curves or between a curve and a line. Now, if you notice, there are no limits given, and these limits, they will coincide with the values, the x values, where these two curves intersect. So that's the first thing we need to find. So I have a list or directions, so to speak, of how to evaluate this shaded area. So first we'll find the points of intersection if they're not given, and that's, like I said, are where the two curves meet. Then we find the area under each curve and then subtract the smaller area from the larger area. Now, this works. This step works. These steps, sorry, they work. However, if you are given the diagram as you see here, there's a much shorter way to evaluate the area. But first, let's go ahead and find these upper and lower limits. Now, both equations say y equal. So to find these limits, we're going to equate these two equations. Equate both equations. So that gives us the x squared minus 8x plus 24 equated to the 8x minus x squared. So like I said, we're equating both y equations. So we're solving for x. So this negative x squared comes over as a positive, and this 8x comes over as a negative. So when we group, we have 2x squared minus 16x plus 24. And this, we're going to solve the quadratic to get the values of x. Now, 2 times 24 is 48, and we need factors that will give us negative 16. And those factors will be negative 4 and negative 12, because when they are multiplied, they give us the 48, and when they are added, they give us these negative 16. So now my equation will read 2x squared minus 4x minus 12x plus 24. Factor out what's common on this side, which is a 2x, to be left with x minus 2 in the bracket. And on this side, a negative 12 is common, and we have our next x minus 2 in this bracket. So now we have our factors, x minus 2 and 2x minus 12 equals 0. So when we solve for x, it will be equal to 2 and 12 over 2, which is 6. So right away, we see that our limits will be from 2 to 6. Okay. Now back to what I was saying about a shorter method. Now if we look at our diagram, we want this shaded area. Now the area that falls below this curve, 8x minus x squared, includes all of this. And the area that falls below this curve, x squared minus 8x plus 24, just includes this portion. So the idea is, since the area under this curve is much larger than the area under this curve, that's what we will subtract to get this region that's shaded. So what we do, we are going to subtract this smaller function from this larger function. And that's what's been done here. So we have our larger function under this curve, 8x minus x squared, subtracted with the smaller function, x squared minus x plus 20 minus 8x plus 24. And we will simplify that. So we have 8x minus a negative 8x is a positive 16x. Then we have minus x squared is a negative 2x squared. And then minus 24 comes down. So rather than integrating each function, it is much shorter to simply get the one function and integrate. So this is a function we're now going to integrate. So when we add 1 to our power, we get 2 and divide by 2. When we add 1 to this 2, we get 3, divide by 3. And if we integrate 24, we get 24x. So now the function that we're going to plug our limits that we found into is 8x squared minus 2 over 3 x cubed minus 24x. So now let's plug our limits. First we're going to plug our upper limit, which is 6. So we have 8 times 6 squared minus 2 over 3 times 6 cubed minus 24 times 6 in our upper bracket. Negative sign in the middle, minus sign. Now for the lower limit, 8 times 2 squared minus 2 over 3 times 2 cubed minus 24 times 2. Now when we work each of these brackets, 6 squared is 36, 36 times 8 is 288. 6 cubed is 216, 216 times 2 over 3 is 144. And 6 times 24 is also 144. Now these cancel, giving us 0 in our upper bracket. Now for the bracket with the lower limit, 2 squared is 4, 4 is 32. 2 cubed is 8, 8 times 2 third is 16 over 3, and 2 times 24 is 48. When this bracket gets calculated, we get a negative 64 over 3. So minus negative 64 over 3 gives us a positive 64 over 3, or 21 1/3. Now, on this paper, I did the same, well, I did the other method where I found the integral of each function. So I found the integral of the x squared minus 8x plus 24 function to get this answer. Then I also found the integral of the 8x minus x squared function to get this answer. And then we will simply subtract the smaller value from the larger value, giving us the same answer that we got in the previous solution, 21 1/3 unit cube. So this method is much shorter, but whichever one you're comfortable, stick to it. You will get the same answer. Okay, so here we have a question. The diagram shows part of the line y equals 7x and the curve y equals 9x minus x squared. Calculate the area of the shaded region. Now we only have one of the limits, which is this lower limit. So that means we need to find this upper limit. And just as before, we are going to equate the functions to solve for x. Now here I have the functions 7x equals 9x minus x squared. So simply this negative x squared comes over as a positive, and this 9x comes over as a negative. So we now have minus 9 plus 7x, which is a negative 2x. Factor out what's common, which is an x, to be left with x minus 2 in bracket. So now our values of x are 0 and 2. We already have our 0 on our diagram, so that means that this unknown intersection, or this upper limit, is 2. Now that we have our limits, we can go ahead and integrate. Now, like before, just as before, we need to subtract the smaller function from the larger function. Now, here we have our curve, and the area under this section of the curve up to the upper limit includes all of this, and the area under this line only includes this portion. So that means we're going to subtract 7x, this smaller function, from 9x minus x squared, the larger function. And that is shown right here. 9x minus x squared minus 7x. simplified is a minus x squared, and 9x minus 7x is 2x. So this is what we will integrate. Add 1 to this power to get 2 and divide by 2. Add 1 to this power to get 3 and divide by 3. So we are going to plug our upper and lower limit into the function x squared minus x cubed over 3. The upper limit we found to be 2, so we have a 2 squared minus 2 cubed over 3, and the lower limit is 0. 0 into any part of this function will yield a 0. So when we work this bracket, we have 4 minus 8 over 3, which works out to 4 over 3, or 1 1/3. Just as before, there's an alternate method. We can find the area under the function 7x, which was for the line, as well as the area under the curve 9x minus x squared, which was right here, and subtract the smaller area from the larger area, which still yields the same answer of 1 1/3 units squared. Okay, last question. Says calculate the area of the region bounded by the curve y equal x squared plus 2x minus 8 and the line y equal x plus 4. So this curve and line are intersecting. Now, as you see, there's no drawing, so we don't know which area is larger. So in a case like this, we will go ahead and integrate each function separately and then subtract the larger area from, and then subtract the smaller area from the larger area. So here we have the solution. This is the equation of our curve, and we equated it to the equation of the line. And remember, we are doing this to find the limits, because if you notice in our question, no limits were given. So we need to first find those limits. So here are our y equations being equated. So we have x squared plus 2x, and this comes over as a minus x. So 2x minus x is x. We have a minus 8, and this comes over as a minus 4, giving us a negative 12. So we're going to solve this quadratic to get the values of x, which correspond to our upper and lower limits. Now, 1 times negative 12 is negative 12. Let's see where I'm putting that. So we need factors that will give us 1. Those factors will be a positive 4 and a negative 3. Because 4 minus 3 is 1, and 4 times negative 3 is negative 12. So now we have x squared plus 4x minus 3x minus 12. Factor out an x that's common to be left with x plus 4. Factor out a negative 3 that's common to also be left with x plus 4 in bracket. So now we have x minus 3 equals 0, which means x is equal to 3. And x plus 4 equals 0, which means that x is equal to negative 4. So right away we can see that our lower limit is negative 4 and our upper limit is 3. So that's how we can now find the integral from negative 4 to 3 of each function. Let's integrate the equation of the line. We get x squared over 2 plus 4x. And we're going to now plug the upper and lower limit. First, we plug the upper limit in the first bracket. So we get 3 squared, which is 9. Put that over 2. And 4 times 3 is 12. Minus sign in the middle. Now for the lower limit. Negative 4 squared is 16. And 16 over 2 is 8. And then 4 times negative 4 is a minus 16. So this is the value from the upper limit minus the value from the lower limit. When this is added, we get 16 and a half, and put back our minus sign, and 8 minus 16 is a negative 8. Two negative signs together gives us a positive, and this area under the line is 24.5 units squared. Now let's find the area under the curve. So this is our equation of the curve, and we are going to integrate, then plug our upper and lower limit as before. Add 1 to the power to get 3 and divide by 3. Integrate 2x, we'll get x squared. Integrate minus 8, we get negative 8x. Now plug in the upper limit. 3 cubed is 27. 27 divided by 3 is 9. 3 squared is also 9. And negative 8 times 3 is negative 24. So this is the value for the upper limit. Minus sign in the middle. Now for the lower. Negative 4 cubed is negative 64. We put that over 3. Negative 4 squared is a positive 16. And negative 4 times a negative 8 is a positive 32. Here we have 9, 2 9s, 18 minus 24 is a negative 6. Write back our minus sign. And this bracket, when calculated, gives us a negative 80 over 3. When this is solved, it works out to a negative 32 and 2/3. Now, yes, the answer of the area is negative, but what it simply means is that this part of the curve is below the x-axis. That's why we get a negative value. So now, what we will do when we are subtracting is keep this as a positive because the area is in fact positive, 32 and 2/3. So this is our larger area minus our smaller area, giving us an answer of 8 1/6 unit squared.